Children, today in the topic differential equation, we are going to study about the homogeneous functions, homogeneous differential equation, and how to solve homogeneous differential equation. Let's try to understand what are homogeneous functions. Now here it is written that a function fx is said to be homogeneous function of degree n, where n belongs to positive integer, if f lambda x and lambda y can be written as lambda to the power n f xy, where lambda is a non-zero real number. Or we can say that if we represent f xy in the terms of x to the power n f y upon x, or f to the y to the power n g x upon y, then also fx will be considered as the homogeneous function, again n belongs to positive integers, right? Now from here we can conclude that a differential equation of the form of dy by dx is equals to fy upon x or dx upon dy g x upon y will be called the homogeneous differential equation. Now here function is used, that's why this is called a homogeneous function. So here derivative is used, derivative with respect to x, derivative with respect to y, then it will be called as homogeneous differential equation. Alright children, please note down. Okay, let's see how to solve the homogeneous differential equation, right? So here it is given that solve the differential equation dy by dx is equals to x plus y whole upon x, right? Now we have to solve this differential equation. So what we'll do? We will take x common from the numerator. So when we do that, this x and x will get cancelled here. Then we'll get dy by dx equals to 1 plus y upon x. Then what we'll do? We'll assume y upon x equals to v. Right, when we do that, we'll get the value of y as vx when we cross multiply x here, right? Now here when we differentiate the term with respect to x, we will get dy by dx is equals to, so the derivative of y will be dy by dx, and the derivative of vx will be, here we are going to apply product rule. So when we differentiate x, we'll get 1, when we differentiate v, we'll get dv by dx. So first function differentiation of second function, so the d by dx of x will be 1. So we'll get v plus x dv upon dx. So value of dy by dx will be v plus x dv upon dx, right? Now what we'll do, we'll substitute the value of dy by dx here. So when we do that, we'll get dy by dx as v plus x dv upon dx is equals to 1 plus v. The value of y upon x is v. So this v and this v will get cancelled, alright? So we'll get x dv upon dx equals to 1. So from here we can say that dv equals to 1 upon x dx. Integrating both sides then, so when we do that, we'll get integration of 1 dv equals to integration of 1 upon x dx, all right? So when we integrate 1 with respect to v, we'll get v equals to log mod of x plus c. So the value of v when we substitute, that is y upon x is equals to log mod of x plus c, or we can multiply x, then we can get y equals to x log x plus cx, right? Note down the solution please. Okay children, let's see another sum. Now in this sum it is given that y square minus 2xy in bracket dx equals to in bracket x square minus 2xy dy. Right. So we have to solve, this is a homogeneous function. We have to solve the homogeneous differential equation and find the solution, right? So what we'll do first, we will take x square common from both the brackets. So when we do that, when we take x square common from here, we'll get x square. Here we'll get y square upon x square minus 2y upon x bracket in bracket dx, right? And when we take x square common from here, we'll get 1 minus 2y upon x bracket close dy, right? So now this x square and this x square will get cancelled, right? So whatever the differential equation will come with, it will come in form of dy by dx into 1 minus 2y upon x equals to y square upon x square minus 2y upon x, right? Now we can see that what we'll do, we will assume y upon x equals to v. So the value of y is vx, differentiating with respect to x. So the value of dy by dx will be v plus x dv upon dx. So in place of dy by dx, we will substitute v plus x dv upon dx. Now on cross multiplying this term, we will get v square minus 2v upon 1 minus 2v. Cross transfer v that side, we will get v square minus 2v upon 1 minus 2v minus v. When we take the LCM and solve, we will get v square minus 2v minus v plus 2v square whole upon 1 minus 2v equals to x dv upon dx, alright? When we solve, we'll get 3v square minus 3v upon 1 minus 2v equals to x dv upon dx. Cross multiplying the terms, we will get minus 3v minus v square upon 1 minus 2v equals to x dv upon dx, right? Now this can be represented when we further cross multiply 1 upon x dx equals to minus 1 upon 3 1 minus 2v upon v minus v square dx. Integrating both the sides, the integration of 1 upon x will be log mod of x minus 1 upon 3, the integration of 1 minus 2v upon 1 minus v square. When we assume this term as t, we will get log 1 v minus v square plus c. Alright, now on substituting the value of v and simplifying, we'll get log mod of x equals to minus 1 by 3 log xy minus y square whole upon x square, right? The value of y, we have assumed y upon x. So you substitute the value of v here, right? We have continued this sum after this step from here, right? So now what we'll do here, we'll cross multiply 3 this side. So when we do that, we'll get 3 log mod of x equals to minus log mod of xy minus y square whole upon x square plus c. So 3 log mod of x can be written as log x cube, right? Log mod of x cube. And when we transfer this minus log xy minus y square upon x square to the left hand side, it will become plus log x square minus y square upon whole upon x square equals to c. Now it is written log m plus log n. So what is the property log m plus log n? It is log m into n. So what we'll get? It will get log mod of x cube into xy minus y square upon x square. So this x square will cancel with this cube. So x, when we multiplied inside this term xy minus y square, will get log x square y minus xy square equals to c. Now log b base a equals to c, we have studied earlier. If we have to change the logarithmic form into exponential form, it will become a to the power x equals to b. So this is exponential form, this is logarithmic form. Log b base a equals to x can be written as a to the power x into equals to b. So similarly here it will become mod of x square y minus xy square equals to e to the power c. When we remove this modulus, we'll get the value of x square y minus xy square equals to plus minus e to the power c. Now we have assumed this plus minus e to the power c as a. Okay. So the solution of the differential equation will be x square y minus xy square equals to a. Please note down. The answer given in the book, I think it is not correct. Do the corrections there. Okay, children, let's see this sum. In this sum, we have to find the particular solution of the differential equation. And the differential equation given to us as 2xy plus y square minus 2x square dy by dx equals to 0. Given that y1 equals to 2, that means the value of the function y at x equals to 1 will be 2. Alright. So what we'll do, first of all, we'll transfer this term minus 2x square dy by dx to the right hand side. So when we do that, the differential equation will become 2xy plus y square equals to 2x square dy by dx. Right. Now what we are doing, I'm taking x square common from these two terms and cross multiplying 2x square. Both the things at the same time. So when we do that, we'll get 2x square in bracket y upon x plus y square upon x square. Okay, upon 2x square equals to dy by dx. Now this 2x square and this 2x square will get cancelled. Alright. So when we substitute the let y equals to vx, we assume that y upon x equals to v. That means y equals to vx. Differentiating this term, we'll get the value of dy by dx as y plus v plus x dv upon dx. Let's substitute the value of y upon x as v. We'll get v plus v square is equals to x v plus x dv upon dx. Now here this v and this v in the right hand side and left hand side will get cancelled. So we'll get the differential equation as v square equals to x dv upon dx. Now integrating both, cross multiplying and integrating. So this will become 1 upon x integration of 1 upon x dx equals to integration of 1 upon v square dv. We know that 1 upon x integration of 1 upon x is log mod of x, and 1 upon v square or v to the power minus 2 will be minus 1 upon v plus c. Now when we substitute the value of y upon x, we will get log mod of x equals to minus x plus yc upon y. We'll simplify it by taking LCM, reciprocal, and then take the LCM. We'll get this expression. Now we'll say that when x equals to 1, the value of the function y is 2. That means at x equals to 1, y equals to 2. So put x equals to 1, then the value y will be 2. So when we do that, we'll get log 1 equals to minus 1 plus 2c upon 2. Right. the log 1 is 0. So this 2 into 0 will be 0. So the value of c will be 1 by 2. When we substitute the value of c here, okay, here we have to substitute, then the value of log of mod of x will be minus x plus y by 2 equals whole upon y. So when we can cross multiply y and then simplify, then we'll get this answer, or this much is also correct. Right. This is more simplified form. Please note down the solution, children.